Friends, in the last session that we had, we talked about the users of the database, and now in this session we'll be talking about the different types of database structures or different types of database architectures. And there are basically three of them which we are going to discuss. The relational structure, which you can see here, then we'll move on to the hierarchical, and we'll then move on to the network structure, right? So let us first understand what do we mean by this relational structure. Now basically, what do we mean by database architecture? Database architecture is basically how are we arranging our databases, because ultimately what happens is that you have to use the data which is there in the database to cull out some information. So how do you arrange your database? This is what we are going to discuss in database architecture. So one way of doing this is relational structure. You can adopt the relational structure. Now what happens in the relational structure, we'll understand. See, this is an example of a relational structure. Have a look at the columns here: name, drive, at, food, good boy. And this particular table here will have slightly different ones: tag number and height and weight, and this will also have tag number and name and breed and color and age. So this is basically a data of some dogs. So let us understand how this database has been structured. Fine. So you understand that relational structure is the database architecture which is the most recent as well as the most common, because it is very easy to use. Now the database is basically arranged in the tabular format. Now have a look. The database has been arranged in tabular format, in form of tables. Now these three tables are there, and tables are called relations. So basically we have got three different relations. Rows, these are called cases. So the first case here is Fido, second case here is Rex, then we have got Bubbles, Kuzo, and the columns are called attributes or domains. So basically this one is an attribute, name. The second attribute in this particular relation is dry or wet food, and third attribute in this particular relation is good boy, yes or no. Likewise, in this particular we've got three different attributes: tag number, height and weight. Here we've got five different attributes or domains, and if you look at the cases, we've got four cases, right? So now I hope you understand what we mean by cases or tuples or attributes or domains, right? Now let us understand. You can now understand that this data would be stored in this manner. For example, dog name has been given, whether he likes dry food or wet food, that has been given, whether he behaves like a good boy, that is what has been mentioned here. What is his behavior? Good enough, then we'll mention why, otherwise no, right? Here if you look at this particular table, let's have a look at this table. You would find tag number, name, breed. Now breed has also been given, the color has also been given, and the age in years has also been given. However, here only height and weight plus the tag number has been given, right? So if you want to find out, for example, if you want to find out about Fido, what about the Fido's weight or height, you would not be able to find that out using this particular relation only. What you'll have to do is basically this database would be modeled in a manner that the data tables would be interlinked using some common type of data. So here all these tables have been interlinked. For example, these two, have a look at these two, and this is the arrow which shows the domain used for interlinking the two tables. The domain here was name, and the one here is again name. So this has been used to actually interlink the two tables. In this case, these two tables, you would find out that tag number has been used to interlink the two tables, right? And this is how, when you want some information from this database, the information would be generated, right? For example, if you want to find out the weight of Fido, so Fido, here we know. Now first of all, there would be a relationship between these two there would be interlinking between these two. So we can say that Fido's tag number is 1573, and then we'll have to move to this table. 1573 tag number has a height of 15 inch and weight of 21 pounds. Is this okay? And this way the database is actually searched and browsed for some answer, right, some information. What is the advantage of this kind of a database? This is very easy than the other database architectures that we'll discuss. And what is the drawback? It does not suit a very large amount of data. This is limited number of data sets that we had. We only were talking about 4 cases, 4 different dogs we had. But what if there are 4 lakh dogs? Then in that case, it's going to be very, very cumbersome to operate with these kind of tables, right? So you simply cannot work with large amount of data if you are going for database architecture which is relational in nature. Large amount of data spread across tables will complicate the data. Not only this, you will find it slow. The searching for some information would be slowed down. The speed of search would reduce in the sense that you would require more time to make the search. Likewise, you would require more time to access the database, because naturally, since the data has expanded, this kind of structure would become very, very complicated, and that is why there would be a decrease in the access time also. There would be an increase, in the access time also. You would require more time to access a particular piece of information, right? So that is why they are slow to respond to your queries. They are slow to respond to your questions. So when you pose a question to the database, you pose it in the form of a query, so they would not be able to respond to you very fast. They would take considerable amount of time to give you the results of your searches, right? Now let us move over to the next type, which is the hierarchical structure, hierarchy. So here the data is basically arranged in a hierarchy. Now have a look. This is what we mean by the hierarchy. Now the topmost node is known as the root, and then we have the level 1 child at the first level, right? At the second level we have got the level 2 child, right? So this is how the database basically is arranged in a hierarchical structure. Now relationship, as I told you, is stored in form of hierarchies. So there's a hierarchy which has been formed, and the relationships are stored in the form of hierarchies. Records are arranged in multi-layer branch structure. Okay, so this structure is not visible here. This actually it stands for structure. So the records are arranged in multi-layer structures, right? So the records are being arranged in multi-layer structure, which would mean, if you can understand what it means here, see, the first layer is the root, right? Then we have the second layer here, the level 1 child, the third level of the hierarchy here, which is known as the level 2 child, because the topmost is the root. So the second level in the hierarchy would be known as the level 1 child, right? So the records are arranged in multiple layers and they are branched. You can see this branch from level 1 child, we are seeing level 2 child, right? So this is how the hierarchical structure is arranged. The higher record would be known as the parent and the lower record is known as the child. Now please understand what we mean by this. Here the root is the parent and this one is the child, level 1 child. That is why it has been mentioned as level 1 child. However, if you talk about these two, this one is the child while this one is the parent, right? A relationship among records is one to many, which means there would be one parent and there would be many children. There can be n number of children, many children also. For example, here one parent and there are 2 children. Likewise here, one parent, 2 children, one parent, 2 children, right? So these are subordinate records. These are higher records, so they would be known as parents, and in this particular case only, right, they would be called parents, while these would be called this is basically the child. However, if you talk about this, you will find that this is the child while this is the parent, right? So the one which is at the higher level would be considered to be the parent, the one which is at the lower level would be considered to be the child. Now one very important thing that you need to remember is that in hierarchical structures you can access the lower level node only through the higher level node. So for example, if you want to go to a lower level node, let's say you want to go to this particular node, lower level node. Now then what will you do? You will have to access the root first. From there you will get access to level 1 child, from where you will get access to level 2 child. Is this fine? So this is how you can access a child node through a parent node or through the higher level nodes. Is this fine? Now again, if you want to actually access this particular node, the child node, you cannot access this through this one. Why? Because they are not simply connected. So you cannot access this particular node without you cannot actually access this node through this one because it is not connected. You will have to go to this one, right? So this is how the hierarchical structure is formed, but then we need to understand what is the problem with these kind of hierarchical structures, right? We'll understand the problem first. The problem is many-to-many relationships can't be shown. So it is very difficult to show the many-to-many relationship. Now what do we mean by many-to-many relationship? Just a moment. Many-to-many relationship would mean here the relationship is one-to-many, right? One parent and many children, many child. However, if the same child has two parents, and what is child and parent here? This is basically the nomenclature given to the record. So the subordinate record has two parents, means has two higher level records from which it has emerged. Now that is something that you cannot show here. You cannot show many to many kind of relationships here, right? So many to many kind of relationships are just not possible. They simply cannot be shown here, right? There's some technical issue with the laptop because of which there are some disturbances. You'll have to bear with me. Now many to many relationships can't be shown. I have told you already, so I'll not be using the presentation mode now. This is something that you cannot do here. You simply cannot show it here. Fine. Why? Because this is meant for one to many. When there is one parent and more than one or even one child would be okay, but the parent can only be one. However, if there are more than one parent, then it is going to be impossible for you to show this kind of relationship through this kind of particular structure, right? For example, I have given this example. Have a look at this example. A person who is reporting to two bosses. I hope you know that this kind of arrangement is there when we have a matrix organization. The same person could be reporting to two different bosses. Now this kind of relationship cannot be shown by a hierarchical structure. But what is the advantage? It is very simple to understand, and this is good for single roles. Very simple to understand and very good for single roles. When one parent is there and he has got one child or maybe more than one children, this is perfectly fine. But if the same child has got two parents, many to one kind of or many to many kind of relationships can't be shown here, right? So this is what we mean by this particular sentence. Fine. Now let us move over to the third kind. The third kind is called the network structure. And now this is an improvement over the hierarchical structure. Why? In the sense that we can show many to many relationships also, which means we can have more than one parent and we can depict it using the network structure. So if one particular record has more than one higher level records, even then we can make use of network structure to show this kind of an arrangement. So many to many relationships are easy. They can be easily shown using the network structure. So any data element can be linked to any number of other data elements, which means one child can be linked to any number of parents. Earlier, if you remember in the hierarchical structure, one child had one parent only. One parent could have had 2 children, could have 4 children, could have one child also, but one child only had one parent. However, if somehow in your case one child has got more than one parent or one lower level record. Now what do you mean by child? This is the lower level record and the parent is the higher level record. So if one lower level record is basically having more than one higher level records, even then we can make use of network structure. Now what is the whole idea behind having this kind of a structure? We can show complex relationships among entities, many to many kind of relationships, and relationships are stored as linked list structures, and subordinate records can be linked to more than one parent. As I said, many to one relationships are possible, wherein many to one or many to many relationships are possible. In hierarchical there was one to many, one parent and one child or more than one child. However, here if the same child has more than one parent, you can show it here, and that is the advantage of network structure over the hierarchical structure, right? So this is good for multiple roles, where for example you are a subordinate of 2 different bosses because you are working in a matrix kind of a organization, matrix kind of a organizational structure. Even there you are basically actually playing 2 roles, multiple roles. In one role you are the subordinate of one particular boss, in the other role you are the subordinate of a second boss. So basically these are dual roles that you are playing, but then we can depict these dual roles using this kind of a network structure, right? So these were the basically 3 different kinds of structures. These were the 3 different kinds of database architectures which are used generally. Now I hope the difference among the 3 is clearer to you. You can please have a look at this video again in case you find there's any problem, and you can always, in case there are some queries, you can always raise those queries and you can always get them addressed personally also. Fine. So thank you very much for your time. After having talked about the hardware, software and networking resources and data and database architecture, now we are going to move on to the study of some very important components of the management information system. One would be the decision support system, and then the second one would be the expert system, and the third one would be the executive information system. So we'll be taking them up in the next session. Fine. Thank you very much.